Okay, someone asked me if I would kind of explain how to find out where a line intersects a plane. That's a pretty good question. Definitely something you'd be called upon to do in your college career. I don't think you'll ever have to do it in real life, but you'll have to do it in college. So here we go. Well, first of all, I made this problem up. So let me give you a rundown. Okay, basically I just made up a plane, and I made it up. I did it by taking 3 points. I vectorized, these two guys. I crossed them. I got this n vector, which is just the, the perpendicular to the plane vector, and that way I could get an equation for the plane. Because before I do any working, here, before I do any stuff, I have to have this like I have to represent it numerically, right? And same goes for the line. I just chose to use a really simple linear equation right there. So, and here's all I did. I mean, hopefully you already know how to find the equation of a plane and, a normal vector to a plane. And I just, like I said, I just went through here, I crossed them, then I crossed the generic vector and got this plane equation, okay? So, anytime you run into a situation, what I would think, I think would probably be beneficial to you. Oh, and again, let me just run through a couple other things. Here's the line that's going through a plane. We're going to find out where this line intersects this plane. Okay, here's all the points. And then this X, Y, Z over here, this just represents all points on the plane, really, So if you vectorized P and X, or Q and X, or R and X, and did a dot product with this vector, should come out to 0. Okay, so that just pretty much kind of represents all points on the plane, just for that. So, but basically, what you'd want to go about doing, and how I would approach this, is I would first find since I mean, this is just a simple linear equation. I mean, it could be anything. It could be a more complicated linear equation. But just for starters, I want to find a point that's actually on this line right here. Okay, so, I chose an easy example because we know that we don't have to do too much work here. But we know that, for example, 2 is on the line. Okay, 2 is definitely on the line. So let's go ahead and plug it into this plane equation and see what happens. Okay, and ultimately, I basically kind of eliminate 2 variables by doing this, and then I can just solve for z. Okay, so I get negative 20 plus 22 plus 3z is equal to 4. Okay, and that gives me 2 plus 3z being equal to 4. Subtract 2 from both sides, just some algebra. So it looks like z is equal to 2/3. Okay, so it looks like our point, let's just call this point S, it looks like it's going to be 2/3. Okay, I hope you can see that in there. I hope it's not too sloppy. But that's 2/3. Maybe I'll do a different color here. Or just write it down on your own paper while I'm doing it. Okay. Okay, so since we already did some, when I did all my work to find this out, we already did the dot product and everything. It should work out, but let's just double check ourselves, okay? Let's take this line right here and vectorize it, okay? And by vectorize it, I mean we're going to make a vector PS. So let's see if we can get PS. So that'd just basically be 2 minus 1, 2 minus 1, and then it would be 2/3 minus 1. That's really sloppy. I hope you can see that. And that simplifies down to 1, 1, negative 1/3. Okay. So now that I've got, we found our suspect point. Okay. I mean, we're pretty sure that it intersects the plane right here. But what I'm doing right here is I want to make sure that this point is actually on the plane. So now that I have a point here and I've vectorized this line segment, and then I get this, if I dot product both of these two together, okay, just dot n and ps, I should get 0, shouldn't I? So that's how I'm going to double check this, just to make sure. Because I'm a little rusty on this too, I'm not going to lie. So PS and should give me, that should be negative 10, 1 plus 11, 1 plus negative 1/3 times 3. I guess I kind of did this last one out of order, but it doesn't matter with multiplication. So looks like everything's looking okay here because the 3's just cancel out. So PS dotted with 1, that just gives me negative 10 plus 11 minus 1. Well, you know, that's certainly 0. So it looks like, I mean, we got a little mess here. It's kind of colorful, but you know, basically we double checked ourselves and we found out that yes, this point right here, I'll call it P sub O, that is in fact on the plane, and it is where y of x intersects this plane, okay? That's just a basic example. I mean, like I said, very simple. At least you got the concept now. But what will probably happen sooner or later is you might get this thing might be, like y of x could be defined parametrically. Okay, in that case you'd end up with a set of equations, and maybe I'll kind of tackle that next. Another thing, you know, this might not have been a line, it might have been like a parabola, you know, going through there. And it could have been a more complicated, you know, equation. You would have had to just, you know, plug x in, then get y. Still would have got a point, but this is the basic concept. So you know, hopefully this gets you started, and I'll see if I can elaborate on it, because it's definitely useful to know.